All right, hello Math 1 students. Today we're doing both 1.4 and 1.5. 1.4 should be review arithmetic, 1.5 should be review of geometric. So we'll get practice of both today. So 1.4 first. Scott decided to add push-ups to his daily exercise routine. He is keeping track of the number of push-ups he completes each day in the bar graph below. One day showing he completed 3 of 4 days and so forth. So basically a table. If I have x and f of x is push-ups, x is days, right? They give us 1, 2, 3, and 4. 1 is 3, 2 is 5, 7 is 7, 8, 9, 4 is 9. So we should see we're just adding 2 each time. So 10 days, I want the explicit equation. So at 0, minus 2 would be 1. So the function is 2x plus 1. So plug in 10. 2 times 10 plus 1. 20 plus 1 is 21 push-ups. Okay. How many push-ups will Scott do in n days? Well, f of n is 2n minus 1. That's the function I found because we're just adding 2. So at day 0, f of 0. So writing it like this, I'll write f of 0 should be 1. Because f of 1 is 3, 3 minus 2 is 1. All right. Model the push-ups Scott will complete, including explicit and recursive. Well, we already found the explicit. And then therefore the recursive is the now, is the previous, plus the rate, where if there was 0 days, we would start with 1. All right, that's recursive. Ali is also including push-ups in her workout. She says she does more push-ups than Scott because she does 15 push-ups a day. Is she correct? Well, let's go back to our table, right? We had 0, 1, 1, 3, 2, 5, 3, 7, 4, 9, 5, 11, 6, 13, 7, 15, 8, 17, 9, 19, 10, just like I thought, 21. Because we're adding 2 each time, right? So the answer is yes and no. Because before day 7, Ali does more. On day 7, they do the same. And then after day 7, Scott does more. Right? Because the pattern continues. He's not just doing 15. He's adding on each day. So that one's a yes and no based on my table. So explain. I showed the work. Showing the work is explaining. So that's our review of arithmetic function. Now let's look at the geometric one, 1.5. So basically, this is a chain email, right? All of you may not know chain emails because you're, high schoolers, and email is older for you. But you might wonder how they receive so many chain remains unbroken. To figure this out, it takes a day to email to be open, forwarded, and received by the next day. Emails. So day 1 sends out to 8. Day 2 send out to 80. Day 3, those 80 people will send out to 10, so that'll be 800, and so forth. So how many people receive it on day 7? So let's do 4. That'd be 8,000. All we're doing is multiplying by 10. Okay, 5, 80,000. 6, 800,000. So 7 would be 8 million. So the answer would be 8 million emails. Okay, I could make an equation because we're multiplying by 10. So f of x equals 10 to the x times, we're multiplying by 10. That means I need to do 8 divided by 10 first. So that'll become 4/5 because 8 divided by 8 tenths times 10 is 8. 4/5 times 10 is 45ths or 8. So it'll be that times 4/5. Plug in 10 or plug in 7. 10 to the power 7 is 7 million, or sorry, do my calculator, wherever I put it. Ten to the power 7 times 4 divided by 5 gets you to 8 million. All right, and there you have it. 10 to the power 7 times 4/5 is 8 million. So 2, they want to receive email on end days. I want explicit and recursive. We just found the explicit. 10 to the power, end days, sorry, times 4/5. And this is the now is the previous times 10 when f of 0 is 4/5. Okay, so that's both. If they'll give away a Super Bowl that costs $4.95 to every person that receives the email during the first week, how much would he have spent? Well, the first week is the first 7 days. So that'll be 8 million times 4.95. And my calculator says 123 times 4.95. He would have spent 396. 1, 2, 3, 4, 5. So that'll be $39,600,000 spent. And that's how we do the math for geometric and arithmetic sequences. I hope that was a good review of both. Thank you for